Come on, come on, come on, come on. Yes! All right, perfect. All I gotta do is wear this hat, this jersey, order a double-double 1 hour before game time every game, and we're gonna win the cup. You should eat eggs every day. You should never eat more than 3 eggs a week. Burning fossil fuels actually doesn't harm the ozone layer. There's just no way to put on muscle without supplements. Some of these statements are true, and some of these statements are false. But how do we determine what's true and what's false? Well, let's back up even a little bit further. How do we go from knowing anything but from, what we think works to actually being able to prove how we know that it actually works? Well, this question is the fundamental concept of the scientific method, which is our topic for today. And its purpose is to determine truth, determine what's true, what's false, and how we can have confidence in what we actually know. And the process for determining this has changed quite a bit over time. Long time ago, we'd have philosophers that spend a lot of time thinking and trying to rationalize how things work, what we should do, and what things are going to end up being true. And it wasn't until people like Francis Bacon, Aristotle, and Galileo that we actually thought about building experiments, testing our thoughts, and seeing what the results were when we measure them. So in this video, we're going to take a look at variables and how we can design an experiment best as possible to determine what's actually true information and what is not. So let's take a look at the scientific method. All right, let's start with a definition here. The scientific method is a systematic process for acquiring new knowledge by making observations, questions, forming testable hypotheses, and then conducting experiments to test those hypotheses, which is basically thoughts or guesses, analyzing the results and drawing conclusions. So building good experiments, analyzing the data so we can figure out what is real and what is not. And it's good that we measure the results because sometimes humans aren't the best at measuring things with our senses. For example, are these lines straight? Or does the moon ever look bigger to you when it's maybe orange and on the horizon compared to when it's up in the sky? Those are optical illusions because these lines are actually straight. If I draw some lines and remove the background, those are completely straight lines, even though they probably seemed crooked. And another little optical illusion I noticed is when I put the pattern on there, it looks a little bit lighter green near the dark squares and a little bit darker green near the white squares. I don't know if you'll get that on the screen, but it seems like a slight change in color, but when I remove the background, again, it's all the same color lines. I don't know if this will show well on the screen, but there's probably a time where you've seen the moon, it's been a bit lower close to the horizon, and it appears a lot bigger. Now, the moon can be a little bit bigger or a little bit smaller based off its orbit, but it's pretty much the same size the whole time. So often when we see this, it's not because the moon's closer, it just appears bigger because it's close to other things that our brain can understand, what a building is, what a city is, and we know how big those things are. So when we see the moon in comparison to it, our brain goes, oh, that looks like a really big object. But then when we see it up in the night sky, there's nothing to compare to. It doesn't really seem as large. But again, for most of the time, if you take the area that's taking up in our field of view and compare it to the other moon, they should be pretty much the exact same. So we want to design an experiment that will give us good results and that we can measure the results instead of just trusting what we see or think. So we're going to put some variables here to design our experiment. There are going to be 3 types of variables. Let's start with the first 2. Our first type is a manipulated variable, and it's the thing that we're changing. So if you wanted to determine if having a snack before bed made you sleep better, the thing that you would change is having a snack before bed compared to not having a snack before bed. That would be the thing that you're changing and that you're intending to change in the experiment. Next thing that you're going to measure, in this case would be, well, did I sleep better or not? That's going to be called the responding variable, something that we can measure and determine, did this have the effect that we expected or did it have an opposite effect? What's the effect of changing our manipulated variable? So let's do another example. Let's consider you want to see if hot chocolate has an effect on people's behavior. Maybe it seems like a bit of an odd choice for an experiment, but I chose this because I have a graph on this topic. I have a graph that shows our hot chocolate drank throughout the year and the amount of car accidents. Okay, so let's take a look. The orange line is the hot chocolate, and as the hot chocolate drink seems to go down, the amount of collisions seems to go down as well. Interesting relationship. Then as the amount of hot chocolate seems to go up the amount that we drink, it seems like the amount of crashes drastically goes up. So this might lead you to conclude, I think hot chocolate is making people impaired. I think hot chocolate's making people so people can't drive very well. Maybe they're feeling a little bit kind of woozy, kind of dizzy, can't focus, and it's causing accidents. But before you call the paper and put in an article that says hot chocolate impairs driving, maybe we should consider if there's any other factors here. Well, this graph is supposed to show what's happening over the course of a year. January would be the far side, December would be the closest here. So there's another factor that maybe is causing both of these, and that factor would be snowfall and temperature. So when it's in the colder January, February months and December, November months, there's going to be more snowfall. It's going to be colder. The snowfall could make the drivers drive a little bit more difficult because there's going to be ice on the roads and snow. But also when it's colder, that's when people are going to be drinking more hot chocolate. So it seems like the snowfall and the temperature probably are causing both of these. I don't think the hot chocolate's really impairing people for driving. So that's just showing that we also have to be aware of other things that could be affecting our result, affecting our responding variable. So that's what's going to bring up our topic of the next type of variable, which is called controlled variables. Controlled variables are what we keep the same. So you have to consider, is there anything else that would affect our responding variable? And if there is, let's try and keep those the same. Because in that last case, I want to see the effect of hot chocolate, not the effect of snow, or not the effect of type of tires, or not the effect of the age of the driver. All those things. If I'm trying to measure the effect of the hot chocolate, I don't want there to be anything else that's going to affect behavior. That's kind of the idea. So let's take a look at some examples. Our first example here says, outline the variables of an experiment to determine how watering plants affects their growth, how water is going to affect plant growth. Okay, so we're going to build the experiment just by listing these variables. So how does water affect plant growth? That kind of gives us already the first two variables. Water affecting plant growth. What we're going to be changing is how much water it gets, none, a lot, a little, and then what we're going to be measuring is the growth. So manipulated variable would be how much water the plant is going to be given. That's what we're changing. We're changing that one on purpose. The responding, we want to measure how much it grows. So I put plant growth there, but I think to get like a full mark in a class here, you can't just say growth. We need something we can actually measure. So how are you actually going to measure plant growth? There's a couple things. We could measure the mass of the plant. We can measure the number of leaves, the height, the length of the stem, things like this. But you have to put in things that you can actually measure instead of saying, oh, it grew. We need a number to measure and actually see how much. Next, we have to think of, is there anything else that would affect the plant growth that wasn't the water? Because maybe one grows really well and one doesn't grow really well. Are we sure it was the water? Was there anything else that could have affected it? Okay, so other things that could affect growth. Type of plant. Some grow faster than others. Original size of plant. Okay, maybe if it was small, it's not growing as fast anyway. The temperature, that's going to have effect on plant growth. The pot, maybe it's already reached its maximum size that it can grow in the pot. The soil, the nutrients it's getting from there. Sunlight, there's a whole bunch of things that will also affect growth. So I want to keep all those things the same so we can just determine the water's effect. Hopefully that example's helping it make sense. Let's try one more example. This example says, which protein powder is the best? So design an experiment to figure out which protein powder is the best. Just a quick note here, protein powder is not required for muscle growth and it's a supplement, meaning you should always consult with a healthcare professional to see what is best for you. This video does not promote or deter the use of protein powder, it's just merely being used as an example for the scientific method. Okay, so which protein powder is best? What we're going to change is the protein powder. Is this one better than that one? We're going to have to change the type of protein powder. What we're going to measure is which one's best? Which one's the best one? Well, that's pretty vague, which one is best. And that was the intention of this example. Like, there's sometimes different thoughts of what makes things something good or something bad. So we can measure a whole bunch of stuff. As long as we're only changing one thing, we can look at how that affects a range of things. So maybe someone's interested in how much muscle mass they gain, how big they're going to get. Someone else is just focused on strength. Someone else thinks the best protein powder helps you with endurance. Someone else thinks it's which one's the healthiest for you. Someone might even think which one tastes the best. So we might want to look at a range of things and get data on those. So someone who is looking to buy a protein powder might want to consider all these factors and they get to choose which one they think is best from this list. So we can measure lots of things in an experiment. Next, going to the controlled, I want to see, is there anything else that would affect those? Now that's a lot of topics to look at. So I'm going to go to like muscle mass and strength. That's what I'm going to kind of have focus on for the responding. What else could affect that? Well, exercise duration. If someone is going to be working out for a short time or someone a long time, that's going to affect how they're going to put on muscle or how much stronger they're going to get. Exercise intensity. If someone was lifting a lot of weight, someone was lifting a little bit, that would also affect how much muscle they're going to get. Exercise frequency. Do they go 5 times a week? Do they go twice a week? That's going to affect how much muscle they get. Diet. And it's not just the only thing you're probably going to be eating. There's probably a lot of other stuff as well. So the diet should probably be the same in this experiment. The amount of sleep, that's going to affect how fast you can build muscle back. And age. The reason why I started age here is that probably would affect the ability of someone to put on muscle, but maybe that's considered in, what we want to know. Is this better for younger people or older people, or is it the same for all of it? So although that can have an effect, that might be something we actually kind of want to include in our results. This worked really well for older people, not as well for younger people. Something like that could be useful information. So the reason why I did this example is because you really want to define best. You want to pick some things that you can measure, and you can do more than one. The other thing I want to put is you don't always have to control everything, because sometimes products such as a protein powder are put into the general public. We want to see how it affects different groups as well. So that one is a bit of a harder example, but I think it shows a little bit more practicality on, seeing if something's going to work or if people would prefer to use this compared to if plants need water. We know plants need water, so that was a bit of a already known example. But this one kind of makes you think about other things maybe that apply to your life. So I hope that made sense for you and helped you understand how to build an experiment with the scientific method and look at all those variables. If you found this helpful, we do have a playlist for different science courses. You click on here and just the latest video over here. So thank you so much for watching this video, and I will see you in the next lesson.